Hello friends, in this video we are going to discuss the previous year GATE question number 14. This question they have asked in the exam GATE 2016. So let us read the question. A steady DC current of 100 ampere is flowing through a power module SD as shown in a figure. Okay, so here we are having a power module. Okay, it consists of the IGBT in connected in parallel with a diode. Okay, the VI characteristics of the IGBT, okay, are shown in figure B, and VI characteristics of the diode D are also shown in figure B. Okay, so diode VI characteristic and IGBT VI characteristic. Next, the conduction power loss in the power module in watts is, okay, so our task is to find the conduction power loss. Okay, conduction power loss. So if we check here, we are having the power module. It is nothing but the IGBT and a diode, connection of a IGBT and a diode, combination of IGBT and diode. Okay, if we check the direction of the current, 100 ampere current they have given, yes, it is in the upward direction. Okay, in the upward direction. So whether this IGBT will allow the reverse current? No, right? So IGBT will not allow the reverse current. Okay, so if you check this 100 ampere current, definitely will be flowing through the diode only. Okay, current will not flow through the IGBT because IGBT will not allow the current, reverse current. Okay, so that's why this full 100 ampere current will be flowing through the diode. Okay, so in this case, the conduction power loss, yes, we can write conduction power loss is equal to conduction power loss is equal to what? Yes, the power loss in a diode only. Power loss in a diode. In a diode. Why it is only in a diode? Because the IGBT is not allowing any current. IGBT is not carrying any current because IGBT will not allow the reverse voltage. Okay, means IGBT is acting as an off state, or IGBT is acting as an open switch. Okay, so here if you check the VI characteristic of a diode, VI characteristic of a diode, okay, it is like the voltage across the diode, on state voltage across the diode is 0.7 volt, and after that the dV by di, that is nothing but the rate of change of voltage with respect to current, that is nothing but the resistance. This indicates the on state resistance of the diode. Okay, so here can we represent this diode, right, as IGBT is in like an open circuit, so 100 ampere current is flowing through the diode only. Okay, so now can we represent this diode as, right, can we represent this diode as, yes, a combination of a voltage source which is equal to zero point 0.7 volt, that is the on state voltage drop of a diode, and here the resistance of a diode which is equal to 0.01 ohm. Okay, so here this indicates, yes, this combination indicates a equivalent circuit of a diode. This is a diode when it is a on state, right? How I have drawn this equivalent circuit of a diode? Yes, from the VI characteristic of a diode we can draw. Okay, this zero point 0.7 volt, it indicates the on state voltage drop of a diode. Okay, so I have indicated it with a 0.7 volt. Okay, be careful, the positive plate should be at the lower side, negative plate should be at the upper side. Okay, this current is 100 ampere. Okay, 100 ampere, and after that, yes, the diode is offering a 0.01 ohm resistance. Okay, during its on state. Okay, so here can we find the power loss in a diode? Therefore power loss in a diode, yes, power loss in a diode is equal to, if we check, it is equal to, yes, 100 into zero point 0.7, right? This is the voltage into current, that is nothing but the power loss. Okay, plus power loss in a resistor. This resistor is nothing but the equivalent resistance of a diode when it is in the on state. Okay, so is equal to I square into R. So it is a 100 square into what? It is a 0.01, 0.01. Okay, so if you check, it is equal to, yes, 100 into zero point 0.7 plus 100 square into 0.01, right, into 0. It is a 170 watt, 170 watt. Okay, so this is the power loss in a diode, which is nothing but the conduction power loss, which is nothing but the conduction power loss. Is this clear? So this is the numerical answer type question. Okay, this question they have asked in the exam GATE 2016. Okay, so in this way we can find the conduction power loss of a diode. Okay, In the next video, we are going to discuss the previous year GATE question number 15. Thank you.